One of the most common questions I see from either new ham radio operators or people looking to get into parks on the air is what type of battery to get and how big a battery to get. When I got back into ham radio about 1.5 years ago at the beginning of 2024, I did a lot of research, watched a lot of videos, saw a lot of recommendations, and ended up buying a lot of things that I either didn't use and wasted a lot of money along the way. So I figured I would make a video and kind of show you what I found works for me, a few different types of batteries, their advantages and disadvantages, whether you're running QRP or running 100-watt radio. I'll also cover how I charge them at home and in the field. And I hope this video might help a few people save some money and time. First, I want to talk a little bit about the few different types of battery chemistries, the battery types. First, I'll talk about a battery that you probably don't see too often anymore in ham radio is lead acid. These are like your car batteries. They're very heavy and bulky. They have a lifespan of about 300 to 500 charge cycles, which a charge cycle is the lifespan, basically how many times you can fully charge and discharge that battery. With a lead acid battery, if you charge it much below 50%, it can decrease the lifespan of the battery. So if you have a 100 amp hour battery, you can really only use about 50 amps out of that battery before you should charge it. The next type of battery is very popular in personal electronics like phones, laptops, tablets, that kind of thing. Battery banks, these USB battery banks, and that's a lithium ion battery. These are very energy dense, meaning they have a lot of energy for their capacity, they have a lot of capacity for their weight or volume. So like this little battery right here is a 10 amp hour battery. They have a lifespan of about 300 to 500 charge cycles. You might notice your phone after about 2 years, the battery life starts to degrade pretty quickly. And that's because you're approaching that 300 to 400 charge cycles. You can drain these batteries to about 80% of their capacity without damage. They usually have a battery management system that will help protect them as well. The next battery is probably not used a whole lot in portable ham radio. You'll see this a lot in remote control hobbies like model airplanes and remote control cars. And that's a lithium polymer battery. These are very energy dense, and they also have you can discharge these at very high rates, making them really good for those type of hobbies. For example, most batteries, they'll have like a C rating on them. So like this has 120 C, meaning you can discharge at a rate 120 times the capacity. For example, if you have like a 5 amp hour lithium polymer and has a 20 C rating, theoretically you can discharge that at 100 amp hours, 100 amps per hour, briefly. The issue with these is they're not quite as safe as a lot of the other batteries. They don't have a battery management system. If you drain them too much, it can damage the cells. The cells can swell, and if they're not treated properly, they can catch fire. You also need a special balance charger to charge these that kind of balances out the cells. That's what this balance port is here for. So these are probably not used much, maybe mostly used for something like summits on the air, where you can take a battery like this and run a 50, 100 watt radio for an hour or so. The issue is normally you'd use a 3-cell or a 4-cell battery, and the voltages don't quite line up with what we'd like to use in ham radio. A 3-cell has a charge voltage of about 12.6, so pretty quickly that voltage is going to drop below what the radio really needs to operate. If you use a 4-cell like this one, the fully charged voltage is over 16 volts, which is a little higher than most radios will accept. I've used this battery for summits on the air with like my G90 and haven't had an issue, but you could use something like a buck converter and drop the voltage down to something that's more acceptable for the radio. And finally, I want to talk about the battery that's probably most common in ham radio, and that's a lithium iron phosphate batteries. These batteries are extremely popular these days for a lot of good reasons. The main one is they have an extremely long life cycle or lifespan. Usually you can get 2,000 or more charge cycles from a battery, so it should last you many years. In fact, I've seen some battery manufacturers advertise, 8,000 charge cycles. So I mean, a battery can last, 8-10 years if treated correctly. These are lightweight and energy dense, but not nearly as energy dense as, say, a lithium ion battery. You can drain these to almost 100% of their capacity. So this 20 amp hour battery, you can get almost 20 amps out of the battery. They're very safe. They're less toxic than some of the other batteries. They don't have some of the heavy metals like cobalt in them. They traditionally have been more expensive. However, recently, these batteries have come down a lot in price, making them a lot more affordable. In fact, there's a lot of affordable brands that are very reasonable. To charge these batteries, they use a little bit higher voltage to charge them, so you typically need a specific charger to charge these to full capacity. Speaking of battery capacity, that's another question that gets asked a lot. How big a battery do you need? And you can go in the weeds with this and get really sophisticated estimates of how much power you're going to use. And I've seen some very advanced spreadsheets, but I like to keep it really simple. Basically you just need to know how much power the radio uses on receive and how much it uses on transmit. And then you need to figure out your duty cycle. How much time are you going to be transmitting? How much time are you going to be receiving? And your mode also plays into this. I'm mostly a CW operator. And so when you transmit CW, it transmits at the full power. So if you're drawing 10 amps at 100 watts, you're going to be drawing that when you transmit. If you're using something like single sideband, the power actually modulates with the volume of your voice. So you won't be using as much power as, say, CW or digital modes. But for example, if you take a radio like my FT891, it typically uses about 1 amp on receive and about 10 amps on transmit, give or take, depending on how much power I'm running. And I usually kind of do conservative estimates, saying I'll probably transmit 40 to 50% of the time. The duty cycle will be about 40-50% of the time. So that's a very simple calculation. On transmit it uses 10 amps, so a half an hour transmitting, 50% duty cycle will be 5 amps. 1 amp on receive, that'll be half an hour, that'll be half an amp on receive per hour. So you should add those two together. 5 amps plus half an amp is 5.5 amps. So say I have a 20 amp hour battery like this one here. You can get about 3.5 hours of operation running my FT891. So a 20 amp hour battery is a really good size, I think, for 100 watt radio, such as the FT891 or the FT710, and even like a 7300. So if I'm using a radio that's only like a 20 watt radio, like a G90, a good size battery that I probably recommend is like a 6 amp hour. You can still probably get 2.5-3 hours out of this 6 amp hour battery with a G90 or say an FX4CR. The two batteries that I use the most out in portable operation are built into battery boxes, and these are both lithium iron phosphate batteries. This is a 20 amp hour battery, and this is a 50 amp hour battery. And the reason I built these into battery boxes is to give me a little bit more versatility. First of all, I have battery monitors on here, And I really like having these battery monitors. And this isn't a voltage monitor. This is a battery monitor that has a shunt in it. And so it's a low resistance shunt between the negative terminal and the load. And what it does is it accurately monitors how much current is coming into the battery and going out. So you get a real-time reading of the battery capacity, how much battery capacity you have left. The other thing I like about these battery boxes is I have Anderson power poles. I have 3 on this box here, and I also have USB ports. I have USB-C PD and just USB-A ports, which is very handy for charging phones, tablets, laptops out in the field. You can even run something like a Starlink off of that. So, and these are pretty simple to build. This battery monitor is the same one I installed in my camper a few years ago, and I've really liked it. It's very simple, it's very accurate, very easy to use. This was my first battery box, and this battery monitor works fine. It doesn't keep a track of how much goes in and goes out. It just has a running total of how much goes through this shunt. So after I charge it, I have to reset that to figure out how much I've used. But it also has USB and power poles as well. I put lights on this one as well. I don't use them a ton, but they're there if I need them. So if I'm doing a shorter activation, I'll usually use this 20 amp hour. And if I'm using doing a longer activation, I'll use the 50 amp hour. A little bit about battery brands, and this might be a little touchy subject. It shouldn't be, but it can be. If you followed any ham radio YouTubers, you'll notice that one brand of lithium iron phosphate battery gets recommended more than any other, and that's Bioenno. I don't own any Bioennos. I don't have anything bad to say about them. For me, I did a lot of research and I just didn't see any evidence to justify the cost of them. They're about 2 to 3 times the cost of most of the other brands. I also didn't see really any in-depth reviews that, tear down reviews like I've seen with the other battery brands. There's a few battery nerds on YouTube that will tear down the battery and just do a torture test on every single feature of the battery management system. So for me, I think there are better brands for the value. However, I have friends that have Bioenno batteries and they love them. In fact, they rave about the customer support. And I have a friend that had a small issue with the Bioenno, and they sent him a brand new battery, no questions asked. But you're paying 2 or 3 times the price. For a 6 amp hour lithium iron phosphate battery, this lifetime is about $30 to $40 depending. It was $30, but I think they're a little bit more with tariffs. But a Bioenno battery with the same capacity is $80. So it's not a ton more, but you can buy 2 of these for the same price. As you go up in capacity, the Bioenno batteries are even more. 100 amp hour Bioenno battery is about $650. You can buy a WattCycle 100 amp hour battery for about $200. So it's over 3 times the price. Plus that 100 amp hour Bioenno, I don't think it has nearly the features that like some of the newer batteries have. A lot of the battery management systems on the newer batteries, especially as you get larger in capacity, like the 100 amp hour batteries, they have Bluetooth that you can monitor the charge state. They have cold charge protection. With the lithium iron phosphate battery, that's the one way you can damage them. If you charge them below freezing, you can damage the cells. So some of the battery management systems will protect the cells and not let you charge them when it's freezing. That's not a huge issue for me here in Texas, but if you live up north, that's probably something to look into. A few of the brands that I prefer, LiTime is one of my favorite brands. This is the same brand I put in my camper. I have a 100 amp hour LiTime battery that I've had in my camper for a few years and had great results with it, never had an issue. So I'm really happy with this. This is not the cheapest brand, but there are really good teardown reviews of these batteries, and they have really good things to say about them. In my new battery box that I use most, my 50 amp hour, this is a lifetime battery. They don't make a 20 amp hour, they make like a 6 amp hour, and they kind of jump up to 50 amp hour and then go bigger than that. I also have some no-name brands. This is Nurmac, I think that's how you pronounce it. I've had this battery a while and it works great. I don't have an issue. You know, I've drained it. It has full capacity. The BMS seems to work great. I haven't seen any teardown reviews of this, but it's a budget brand. They're probably around $50. This battery, I actually just replaced the battery a few months ago. It's a WattCycle now, 20 amp hour. I think those go for around $60 brand new now. That could fluctuate a little bit with the tariffs. But a great battery. I've had nothing but good results with it. I had actually had a used lithium iron phosphate battery in that battery box for hundreds of activations, and it worked great. When I first got into ham radio, lithium iron phosphate batteries cost quite a bit more, and my brother had recommended this brand. It's a very high-end battery called K2 Energy, and these are used for a lot of commercial purposes, and they'll replace them way before their life cycle or their lifespan. And you can get them pretty cheap on eBay, but honestly, most of the time you can buy a brand new like WattCycle for what you could get this for. So this battery, I think it was manufactured in 2016, and it still has nearly a full capacity on it. So that's a little bit about battery brands. That's not all the battery brands. There's quite a few of them out there that all seem to work pretty well. Some of the other battery brands that I don't have, but I've heard good things, are EcoWorthy. You can get a 20 amp hour EcoWorthy for about $50 to $75. I think there's another one called Expert Power that's pretty decent. A little bit about solar generators. This was actually the first battery I used because I had it when I first got into ham radio. I had it for camping, and I used this battery quite a bit with my G90 before upgrading to a lithium iron phosphate battery. This is an older solar generator with a lithium ion battery. I got it refurbished pretty cheaply, and it works fine for what it is. I wouldn't say this is a great option for ham radio, simply because the 12 volt ports, you got a cigarette lighter and you got barrel connectors, and those really, you shouldn't, you know, those kind of have a current limit of about 10 amps. I probably wouldn't run 100 amp hour, or excuse me, 100 watt radio off of this. You're kind of reaching what those connections, the barrel connector and the cigarette lighter adapter, is made for. But for a smaller radio, either a QRP or a G90 or something like that, this would work fine. I haven't had any issue with the 12 volts as far as interference goes. However, with the built-in inverter, it may cause some radio interference if you're using that. It does have a solar charge, a solar charger built into this, so you can hook up a solar panel directly to this and it'll charge, which is convenient out when you're camping. As far as charging goes, you can buy lithium iron phosphate chargers that are specific, like this one. I would not recommend this charger. I barely use this. This is one of those things I wasted money on. If you plug this in, even if it's not hooked up to a battery, I get S9 noise level on my radio. I can't make a contact if I'm using this. But it does work. It works fine. It's just very noisy. So you might look into that before buying a lithium iron phosphate charger. How I charge my batteries, for the most part, is just a simple bench power supply that I built a few years ago. This is just a project I did, I don't know, 5 or 6 years ago. It's in a 3D printed case, and it has just one of these cheap, you know, controllers where basically you set the voltage and the current. And so with the lithium iron phosphate battery, you want to be somewhere between 14.2 and 14.6 volts to charge. So when I charge my batteries, I'll usually set this to 14.4, 14.5 volts at 5 amps. And even my 50 amp hour battery, you know, I'll just set it on there overnight or you know, charge it over 4 or 5 hours, and it works great. The battery management system in these batteries are usually pretty advanced, and they will maintain the charge. As soon as they're done charging, you'll notice that it's not drawing any current and you're done. So that's a good way to do it. You can buy benchtop power supplies, and the advantage of that is you can use this for a lot of other things too besides charging batteries. So I think that's a pretty convenient way to charge these. A little bit about charging out in the field. One thing that I use a lot, especially when I'm out doing roves or going from different parks, you know, going from park to park, is this DC to DC charger. Because lithium iron phosphate batteries take a higher voltage to charge, you can't just hook it to your cigarette lighter and expect it to charge. You need to have something that will increase the voltage. And so this is a DC to DC charger that takes your 12 volt outlet and brings it up to 14.5 volts for a lithium iron phosphate battery. And it also, this is a PowerWorks brand, and this works great. You can set it for between 2 amps and 8 amps. I will say, if you're going to use your cigarette lighter adapter, be careful. You can, if you're drawing 8 amps, that's kind of pushing what cigarette lighter adapters are meant to do, and you can either blow a fuse, or a lot of times the wiring in cars probably is not rated for that kind of current. I was using this in my wife's car when my truck was in the shop for a few months, and her cigarette lighter adapter stopped working. I'm pretty sure I drew a little bit too much current, and the wiring probably wasn't built for it. I didn't blow the fuse, but it no longer works. I didn't tell her what happened. I just said it stopped working. Hopefully she doesn't watch this far into the video. So if I was going to use a DC to DC charger quite a bit, I would just run its own dedicated wiring with a thicker gauge wire, and you'll probably be fine. But these work great. The other thing I use to charge lithium iron phosphate batteries out in the field is solar. I have 2 solar panels. I have a big, bulky briefcase style 100 watt Renogy. I think Renogy is the name brand. I don't use it a lot just because it's so bulky. You know, it weighs a ton, and it's kind of awkward to set up. But it does have its own charge controller built in. And it does have a setting for lithium iron phosphate batteries. So I'll use that when I'm camping and I'm going to be out, you know, a day or two. But I have this small, I actually got this at Hamfest. It's a EcoFlow 100 watt foldable solar panel. And that works great. It's easy to throw out on top of my truck bed or on top of my truck. And then I have a very inexpensive solar charge controller here that works great. And these are cheap. I think this is about $38. It's a 10 amp charge controller, and I've used this quite a bit. One thing you have to watch out for though is some of these charge controllers can be quite noisy. So just make sure that if you're going to get one of these, you might want to make sure that it doesn't have any RFI. There are some more expensive brands that are recommended quite a bit that probably are a little higher end, but this works great. I've had no issues with that. Let's see. Let's talk about QRP radios and power. There are a lot of options for QRP radios. You know, there's a lot of small batteries you can use. The main issue with QRP batteries is to ensure that you have the correct voltage for the type of radio. For example, the QRP Labs QMX You can build that to 9 volts, you can build it for 12 volts, and some of the QRP radios are very picky on voltage. A lithium iron phosphate battery may be a little bit higher voltage than those are used to running at, and you can damage the radio. So you just have to be a little bit more careful. But one of my favorite batteries to use is for QRP operating is this Talent Cell. This is a 6 amp hour Talent Cell, and these come, I think this is around $45 these days. So it's a 12 volt battery. It actually has a few 18650 cells in here, lithium ion cells. It has a built-in charge controller, and it actually comes with a little wall wart that'll charge, and a barrel connector. And it's the same style barrel plug that a lot of QRP radios, I think is a 2.1 times 5.5 millimeter. And so you can just plug that straight into your radio. So very, very good battery. One of these will last you all day for QRP, probably multiple days actually. The other way, and probably my more common battery that I use for QRP, is one of these USB power banks. One of these will last a long time. This is a 10 amp hour. They're fairly cheap. So the way that I use these, they have to be USB-C PD. And there are a few, let me see if I can find them here. You have to use a USB-C PD trigger device. Something like one of these where you can basically wire this up. This one in particular is super cheap. You can get like 5 or 6 of these for, I don't know, $10 or something. And this has the option for different voltages. You basically just short out what voltage you want and then just wire up either Anderson power poles or a barrel connector. I have made one of these with Anderson power poles, and I made one with a barrel connector for my Elecraft and other like QRP Labs radios. And then I made one specifically for my mountain toppers. So basically you just plug the USB-C cable into the power bank and plug it into this trigger device, and you're good to go. Works great. And I mean, you know, I've done like an hour-and-a-half activation and used less than 10% of this battery. You can also get pre-made trigger devices like this. This is built into a barrel connector, and that's a 12 volt trigger device as well. So that's a great way to power to power QRP radios. I will say you have to watch out with some of the power banks. Even though this says USB-C PD, this one has issues with some of the radios, and I think it's just not rated for a certain amount of current. I can use this with some things, but not others. A couple other ways to power QRP radios, and like I said, almost anything you can use. I mean, you can even use a 9 volt battery, and nowadays they make lithium ion 9 volt batteries that are USB-C rechargeable. This is actually a very cheap AA battery holder, and I actually have lithium iron phosphate cells in here. These are 3.2 volts each, so they're not their typical AA. I think these are made for like solar lights, and this works pretty well, except for I actually don't have a charger for this type of battery that that is specific to lithium iron phosphate, so I don't get a full charge out of here, but it does work. You can also use like you can make a little holder for these 18650 batteries. I've actually 3D printed a holder and wired one up for QRP radios. These work pretty well, and these are very common cells in like flashlights and stuff. In fact, I've taken them out of old batteries and found the good cells and used them. I think that's about all I have. Hopefully this video will help you decide what type of battery to get. Hopefully it'll save you some time and money. Like I said, lithium iron phosphate batteries are probably my favorite for, go-to battery, unless I'm QRP, and then I would probably use either the Talent Cell or this lithium ion battery. if you found this video helpful, feel free to leave a comment. If I missed anything, please let me know. Let me know your favorite type of batteries. If you like this type of video, let me know, and I might make similar videos in the future, maybe on my favorite portable radios or my favorite antennas. One thing I'm not sure if I mentioned, I might have forgot about this, back to battery monitoring. This type of monitor does work as well. It is not as good as the ones on my battery boxes, but if I'm using a battery that doesn't have a battery box, I'll use this just to see where my charge state is. I don't like this one as much because it will show you the current draw all the time, but the current that you've already used out of the battery, it kind of cycles through and gives you a bunch of information I don't really care about. So a lot of times it takes 30 seconds, 45 seconds of staring at this to get the information you want. So not my favorite. So that's that. I think that's all I got. Until next time, 73.